All right, welcome to 5.7 and 5.8 video. We are going to be looking at the zero product rule for assisting us in solving our quadratic equation, or we could say in general, our polynomial equations. You are going to see your trinomial ax squared plus bx plus c equal to 0. It could be two terms equal to 0. It could have four-term polynomial equal to 0. In either case, we are going to work to factor this to a times a b. So I'm just using arbitrary variables here. As you recall, when we were talking about factoring, we wanted a number, a variable, or a quantity to be all multiplied together. Well, all we're going to do is set that equal to 0. So if two factors are multiplied together, then one of those two factors has to be equal to 0. And what we're going to do is we're going to cover all bases and say all the factors are going to be equal to 0. And these are all the possible answers for the variable to make the equation true. So you could have three factors here. You could have a times b times c, a times b times c times d. So it doesn't matter how many things you multiply together. Once you multiply by 0, everything's a 0. So in my first example, we have 5x, that's a factor, times the factor x minus 2 in parentheses. So 5x plays the role of a, x minus 2 plays the role of b. We set them equal to 0. Now we solve each one individually. To solve for x, you have to, since I'm multiplying 5 to the x, I'm going to divide 5 to both sides. X is equal to 0. Here I have x minus 2 is equal to 0. I'm subtracting 2. I'm going to add 2 to both sides. X is equal to 2. Those are my two solutions for x. X is equal to 0 and 2. Both of those answers will work. All right, here we have three factors. I have a 7, there is a number, and two quantities. Each one of these factors are set equal to 0. Well, hopefully you can see right off the bat that when I set 7, that GCF factor, equal to 0, there's no way 7 can be equal to 0. That's a false statement. We'll throw it out. So in the future, any numerical GCF out in front of my parentheses without an x in it, we'll just disregard. So now we'll solve x plus 8 equals 0, 2x minus 3. So here, subtract the 8 over from both sides, x equals negative 8. Here we'll have to add over the 3 to get 2x equals 3, and then divide both sides by 2 to get 3 halves. There's my two answers for x. Now in this case, three factors again, but now my GCF has an x in it, just like the 5x. So 2x equals 0, divide over the 2, x is equal to 0. So at this point, we're going to make a pledge. Anytime you have a variable GCF, a monomial here, one single term factor, and it has an x in it, no matter if it's 5x or 2x, the answer is always 0. So let's just grab that and declare x equals 0 from now on. Then we'll take x minus 1, set it equal to 0, x equals 1. X plus 1 equals 0, subtract over the 1, x equals negative 1. So in this case, you have three answers for x because there was three factors that included the variable x. All right. So now let's start with trinomials or polynomials here, and now we got a factor to check that these work. And then also what I'll do is I'll show you how to make sure that all your factoring was done correctly and that we do have the right answers. So here we want to take a look at our plus 24. It's a positive. That means my two signs are going to be the same. So I'm looking for an x minus, and what two numbers multiply to be 24 and add up to be 10? It's got to be 6 and 4. So x minus 4, x minus 6 are my two binomial factors. We set each of those equal to 0, and now we solve. Add over the 4, x equals 4. Add over the 6, x equals 6. Here's my two answers. Now what I can do with my calculator is I can grade my answers. Anytime something says to simplify, evaluate, or solve, your calculator can check things out for you. So, for example, on my calculator, there's this STO button. It's right above the on button. You can store numbers in for variables. So we have a 4 and a 6. So I'm going to take the 4, store it for x. Enter that. So every time I hit an x, it's going to say 4. Now I type in my left-hand equation here. X squared, there's x squared, minus 10x plus 24. If I hit enter, it substitutes the 4 in for my x's, and it gives me a 0. Now I want to check the 6. 6, store it for x. Enter. Now, every time I hit x, I get a 6. So I'm going to up arrow to get to my trinomial, have it highlighted, hit enter, it pastes it down below. Now it's going to plug the 6 in for the x's. It gives me a 0, so now it tells me those two answers are correct. X squared minus 10x minus 24 equals 0. Same numbers, but we just changed the 24 to a minus. So, minus, my signs are opposite. So 1 plus 1 minus, what two numbers multiply to 24 and subtract to be 10? It's going to be 12 and 2. So we need the 12 with the minus sign, the 2 with the plus sign. Set those equal to 0. Add over the 12, subtract over the 2. There's my two answers for x. Now you'll notice that I did not write x minus 12 equals 0 and x plus 2 equals 0, because hopefully you've discovered through all these examples that if you look at your binomial example when it's just an x plus or minus a number, it's the opposite sign. X minus 2, x equals positive 2. X plus 8, x equals negative 8. X minus 1, positive 1. X plus 1, negative 1. X minus 4, positive 4. X minus 6, positive 6. X minus 12, positive 12. X plus 2, negative 2. So when we get to these binomials, just change the sign on that constant and set it equal to x. If we have some multiplying, okay, we might want to set that equal to 0 and work through that. Now, I'm going to go back to my calculator here. And let's say I thought the answers were 6 and 4 again down here with this trinomial. So I come back up here, I'll enter that, I put in my minus 24. Okay, I hit enter. Now x is still my 6. So if I had these numbers, notice I get a negative 48 and not a 0. And that way you know, oh, wait a minute, I factored something wrong if I don't get that 0. Go back and check your work. All right, x squared minus 8x plus 16 is equal to 0. Okay, let's factor this. Well, we got a plus 16. It's going to be minus minus because we have a minus in the middle. Signs are the same. What two numbers multiply to be 16 and add up to be 8? 4 and 4. So x minus 4, x minus 4. Well, since these two binomials are the same, you only have to solve one of them. X is equal to 4. And x is equal to 4. So it's equal to 4 twice, but you don't have to write it down twice. We could just write it down once. All right. On this example here, this is a trick question. I fool a lot of people on the test. Never, ever, the first instinct you want to do is, oh, just divide both sides by an x and x will equal 6. No, this has to be set equal to 0 before you can solve it. So we have to subtract the 6x back over to the left side, so it's now equal to 0. And now since I have a binomial, both with an x in each term, I need to factor the x out as the GCF, and I'm left with x minus 6, and now x is equal to 0, and x is equal to 6. There's my two answers. Over here, 4x squared equals 25. It's not equal to 0. Subtract over the 25. You have a difference of perfect squares. So we're going to have 2x and a 5, one with a plus, one with a minus. So here I'll set the 2x plus 5 equal to 0. I'm going to solve this one. I'll subtract over the 5, divide over the 2, x is equal to negative 5 halves. Now, if you want to solve this one for 0, setting it equal to 0 and go through the work, you can, but notice the only thing difference is the sign. Everything else is the same. So this answer is going to be a positive 5 halves. So there's no reason to show the work for this one. Since you've already done that, all you have to do is change the plus to a minus, which makes that a positive 5. So it's just a changing of the sign. And there's my 2 answers. All right, solving the equations by factoring. X squared plus 16x plus 63. All right, x plus something, x plus something. What 2 numbers multiply to be 63 and add up to be 16? 9 and 7. So x equals negative 7, x equals negative 9. There's my 2 answers. Whoop, we're not equal to 0 here. Subtract over the 28. All right, we need 1 plus, 1 minus. 2 numbers that multiply to be 28 and subtract to be 12. We have to have a number bigger than 12. So I'm looking at 14 and 2. X plus 14. 14 gets the bigger sign. And x minus 2. So we have x equals negative 14 and a positive 2. Well, we have x's in every term, and every coefficient is even. So let's take out a 2x. And then we have x squared plus 4x minus 12. We'll factor that. We're going to have a minus, so 1 plus 1 minus. What 2 numbers multiply to be 12 and subtract to be 4? 6 and 2. 6 gets the plus sign, 2 gets the minus sign. And so now this 2x out here, and you could have done this on the previous step, is once you take out a GCF that has a variable x in it, recall we said x is automatically 0. So you could have declared x equals 0 and then leave off the 2x. You don't need it anymore. X minus 2, change the sign, x equals 2. X plus 6, change the sign, x equals negative 6. Those are my 3 answers there. And again, all of these are gradable. 6x squared minus x minus 35 equals 0. All right, this one's going to take a little more work factoring. That 6x has to lead off both binomials. It's a minus 35, so 1 plus blank, 1 minus blank. This is what my answer is going to look like. Now we're going to go solve it. Or factor it, I should say. All right, so what 2 things multiply to be 6 times negative 35 and add up to be a negative 1? 1 is odd, so that tells me I need odd factors. 1 odd, 1 even. I need to find this odd factor. Now, the other thing that's nice here is that this is a 1. That means my 2 numbers that I find have to be right next to each other, like 7 and 8, 9 and 10. So when I break these numbers down, 2 and 3, 7 and 5, I'm going to start to look at them and try to figure out how do I want to trade these factors so I get 2 numbers really close to each other, where they're only 1 apart. So let's see, what I usually like to do is take the smallest factor and match it with the biggest. 2 times 7 would be 14, and then 3 times 5 is 15. They differ by 1. There's my numbers. And 15 has to carry the negative sign. So in the minus blank, we'll put the 15. In the plus blank, we'll put the 14. Now we'll take out our GCF of the first blank, which is a 2. Gives me 3x plus 7. And we'll take out the GCF of my second binomial, which is the 3. Gives me 2x minus 5. Set those both equal to 0. And now we solve. So we'll subtract over the 7, and we'll divide over the 3. 2x minus 5 equals 0. We'll add over the 5. We'll divide by the 2. There's my 2 answers. All right, next example. Very similar to this one. All right, our next example here, 8x squared plus 30x minus 27. So I see a minus 27. So we're going to have 8x plus something, 8x minus something. And we're going to break this down. So what 2 numbers multiply to be 8 times negative 27 and add up to be 30. 30 is even. 8 is even. So we're looking at even plus an even. Now, in this example here, normally I think last time we saw an 8, we broke it down to 4 times 2. But this time I'm going to go with all the 8s because the 27 breaks down to 3 3s. Now, if this number only broke down to 2 factors, say it was a 15 and it was 3 and 5, then I would make this a 2 and a 4. But because we have all these factors, we don't know what's going to be the combination 1 3 with 1 2, 2 3s with a 2, 3 3s with a 2. We're going to have to roll this out and see what we get. So I went with all 2s here. So I'm going to take a pair of these 2s, one each for each even number. Remember, every even number is divisible by 2, so there has to be at least 1 2 being multiplied to that number. We'll cancel those out. Then take the 30, divide it by 2. So now what's in the parentheses here has to add up to be 15, which makes this an odd. Okay, so now that's going to leave me some choices here. We'll start with 3 times something. Well, 9 times 2 is 18. 18 and 3 will subtract to be my 15. So there's going to be my numbers. So 18 is going to have to carry the plus sign because it's positive. So just to double check, 2 times 18 is 36. 2 times negative 3 is negative 6. And 36 minus 6 does add up to be that 30. And it's going to multiply to be the same as up here. So 36 goes in the plus blank. Negative 6, we'll put the 6 in the minus blank. So there's my 2 factors. Now, because we're solving, this is allowed to save yourself some time. I'm not a fan of it, but it's still mathematically correct. You do not have to divide out the GCF. You can set the binomial equal to 0 right away. Now, if we look at this really close before we solve it, the GCF would be a 4. I'll show you in the work where you divide out the 4. So we subtract over the 36, we divide over the 8, and now in fractional form, you'll reduce this by 4, and that's where you remove the GCF of 4 to get a negative 9 halves. 8x minus 6, the GCF would be a 2. I'll show you when we're going to get rid of the 2. Set it equal to 0, add over the 6, divide by 8. 6 over 8 reduces by 2. That's where we remove the GCF of 2. This is where you're removing it here. So you either take it out at the beginning or you can take it out at the end. Either way, it's pretty much the same amount of work. So my answers are negative 9 halves and 3/4. So if you wanted to double check your answer here, I'm going to go grab my calculator again just to show you how this works. Clear my screen. Remember, x is still the 6 from before. I'm going to enter a negative. Now I can do fractions here. Alpha y equals gives me a fraction. Choose option 1. 9. Then down arrow to the denominator for a 2. Right arrow out. Store it for x. Enter. Okay, type in the original problem. 8x squared plus 30x minus 27. Remember, there's a difference between the negative sign and the minus sign. Just to show you, there's a difference in what they look like. So make sure you're using the appropriate symbol. All right, if I'm right, this should be equal to 0. It's a 0, it works. Then if I want to check my 3/4, I'm just going to go up to where I had my fraction here and edit my fraction work, delete the negative, put in a 3 on the top, 4 on the bottom. Enter it. Notice it gives me a decimal answer here. I don't care. I just know that it's going to be my fraction. Again, come up here, copy down my trinomial, the left side of the equal sign. Hit 2 equals 0, so both of these are correct. I just graded a test question. How dare I get you to get an A? Oh, my calculator crashed here. I apologize. That's going to happen in these videos, so we'll just have to wait till it shows up again so I can move it off screen. Oh, again. Oh, it's got problems. All right, sorry for that delay there. All right, next problem. X to the third. Okay, well, wait, this was x squared. Notice we had two answers. If it's x cubed, we're probably going to have three answers. So here, looking for a GCF, whoop, there's no x here, so, and 3 doesn't go into 8. There's no GCF, so this is 4 terms. We cut it in half, and we'll factor by grouping on both sides. So we'll have a plus binomial and a plus over here. So I'm going to take out the x squared to get 2x plus 3. 2x plus 3 is the same as over here. So in order for that to happen, negative 12 divided by 4 is a negative, divided by 3 is a negative 4. Negative 8x divided by 2x is negative 4, so there's my GCF. The 2x plus 3 is the GCF of both sides. And then the x squared and the minus 4 make, oops, wait a minute, that's a difference of perfect squares. They're hiding again. So that becomes x plus 2x minus 2. So here's my three binomials that I can solve for x. So 2x plus 3 equals 0. We'll subtract over the 3 and then divide over the 2. X plus 2 means we're going to have x equals a negative 2 and a positive 2. There's my three answers. And again, you're more than welcome to store those answers for x and type in that, in this case, polynomial for terms and make sure that it's equal to 0. Solve these equations by factoring. Now, big mistake here is some people say, oh, look, it's already factored. X plus 3, just set it equal to 9. No, it has to be a 0. So these problems are what the author like to do is to make you go back. You're going to have to FOIL out the left side. Make sure you're doing your work. And then subtract the 9 over and then refactor it. I know it's a pain. There's no other way around it. There's more work to do. So again, it might be a good idea to go ahead and check your work when you're done. So we'll FOIL this out. X times 2x, 2x squared. X times minus 1, minus x. 3 times 2x plus 6x. 3 times minus 1 minus 3 equal to 9. Combine these two terms. That's going to be a plus 5x. And then I'm going to subtract the 9 over to the minus 3. So minus 3 minus 9 is a minus 12. Now I factor this. Okay, we have a minus 12. That means it's going to be 2x plus something, 2x minus something equal to my 0. What two numbers multiply to be 2 times negative 12 and add up to be an odd number 5? It's odd, so look for odd factor. The only odd factor is here in the 12. 3 and 4. You do not have to break these down because we're going to isolate the 3. We're going to have 4 times 2 is 8. 8 and 3 are my two numbers. 8 gets the positive, 3 gets the negative, so 8 goes into the positive, 3 goes into the negative. All right, so 2x plus 8, set it equal to 0. Subtract over the 8, divide by 2, negative 4. That's where we got rid of the GCF. 2x minus 3, add over the 3, divide by 2. Negative 4 and 3/2 are my answers. Now, to check this one in your calculator, we're not going to use the trinomial because how do we know if we didn't make our mistake when FOILing? We have to use the original. So I'm going to store negative 4 in for x. So negative 4 store x, enter. And now type in the left-hand side. Left parentheses, x plus 3. Close the parentheses, left parentheses, 2x minus 1. Now, this is supposed to equal 9 when my x is a negative 4. I hit enter, there's my 9. If I want to store my 3/2, another way to do your fractions is you can just do the division symbol. 3 divided by 2. Store it for x. Up arrow, grab those two binomials, which is the left side of the equal sign. We paste it in, now it's using 1.5. And I get a 9 again, so now I know those two answers are correct. So here, we got to FOIL this out. It's not equal to 0. So x squared plus 4x minus 3x minus 12. So 4x minus 3x is 1x, but then I got to subtract over the 5x, and that's going to be 1x minus 5x is going to be minus 4x. And now we factor it. So, well, let's see, we got a minus 12, so it's going to be an x plus something, x minus something. I'm looking at x plus 2, x minus 6. There they are. X equals 6, x equals negative 2, and there's my answers. Now, to check this one with the calculator, because it's equal to 5x, to show you what we have to do here is you basically have to type in both sides of the equal sign, and they're going to be true. So I'm just going to do one number here. 6, store it for x. Enter. Type in x minus 3. I took a peek at the other one. X plus 4. That's the left side. That's a 30. Then I type in the right side, 5x. That too is 30. So both sides equal 30. Then we know that this is true. If I store the negative 2, I'll get a negative 10 and a negative 10. And then that way I know this one's correct. So your calculator can grade all these problems for you. You just got to take the time to do it. Okay, 5.8, looking at word problems. Now these word problems, what's going to happen is they're going to create these quadratic equations, polynomials that we want to set equal to 0. So we're going to want to make drawings and label things and everything else that can possibly help us out. So Wooden Work Limited builds cutting boards that are twice as long as they are wide. All right, the most popular board that Wooden Work makes has an area of 800 centimeters squared. What is the dimensions of the board? Okay, so this is a cutting board, and cutting boards are usually rectangular in shape. So long and wide means a rectangle. So draw a rectangle, label length and width, and now we're going to go up here and look at some key verbiage. Twice as long as they are wide. So the length is equal to 2 widths. We got to double that. So that means L is equal to 2W. Now, the nice thing here is we're going to take your area formula, length times width, which is equal to 800, but you can't solve the equation when there's 2 different variables in it. So we're going to take the 2W, replace that L with 2W, put the 800 in for the area, and now we create an equation with 1 variable. So this becomes 2W times W, which is 2W squared equals 800. But to solve this, you set it equal to 0, so subtract over the 800. Factor out the 2 as the GCF, and now you have a difference of perfect squares. We're going to have W plus 20, W minus 20. So W is going to equal a negative 20, and wait a minute. How can the width be a negative distance? It can't. This answer does not make sense, so we're going to throw it out. So the width is 20. Then if we double that width, we get 40 for the length, and there's our answer. It's a 40 centimeter by 20 centimeter cutting board. All right, next word problem. Race numbers. Terry and Jody each enter a boat in the Lakeport race. The racing numbers of their boats are consecutive numbers, the product of which was 156. Find the numbers. So consecutive numbers means they differ by 1. So what we're going to do is we're going to call the first number X. We don't know what it is. But now we know what the second number is. It's going to be 1 bigger. So we're going to call it X plus 1. So the product means to multiply the 2 numbers. So X times X plus 1 has to equal 156. So X squared plus X equals 156. It's got to be set equal to 0, so we subtract over the 156. And now we look to factor this. So we got an x plus something and x minus something, 156, looking for two numbers that subtract to be 1. So again, I mentioned this before, but I'll use my calculator here. I'm going to take the square root of 156. That's 12.489. Okay, the numbers are 12 and 13. 13 gets the plus, 12 gets the minus, x equals negative 13, x equals 12. Well, assuming that the racing numbers must be positive, then we're going to throw out the negative 13. So the first number is 12, and then 12 plus 1, the next number will be 13. Now, I threw in this next example, pretty much the same thing, a little different to it. It says the product of two consecutive even integers is 240. Now it's even integers. So we're talking like 2 and 4, 4 and 6, 6 and 8, 8 and 10. It's going to be 440. So now the first number is x, but because you're even, or even if it's odd, it still differs by 2. So the second number is going to be x plus 2, not the x plus 1 up here. Even and odd will be a plus 2. No even or odd, they're consecutive. You add a 1. So x times x plus 2 equals 440. So distribute the x squared plus 2x equals 440. We'll subtract over the 440, and we'll factor this. Now again, even though they differ by 2, I'm going to go to my calculator. Second square root, 440. 20.97. Okay, they got to be two even numbers, differed by 2, so I'm thinking 20 and 22. Yep, 22 times 20 is 440. 22 gets the plus sign because it's bigger. 20 gets the minus sign. X equals a negative 22. X equals a positive 20. Now, here's the kicker. Integers can be positive and negative. So both of these answers are going to work. So when x is negative 22, negative 22 plus 2 would be a negative 20. There's the pair of negative numbers that multiply to be 440. And when x is 20 and 20 plus 2 is 22, there's the positive two even integers. So this time, our numbers don't represent anything that has to be positive. So integers can be negative and positive. So you got to look out for that trick question there. All right, one leg of a right triangle is 3 feet longer than the other leg. The length of the hypotenuse is 15 feet. Find the lengths of the other two sides. Well, because you're working with a right triangle, we're talking about the Pythagorean theorem. The Pythagorean theorem says that the sum of the square of the legs, a squared plus b squared, the legs are the sides of the 90-degree angles here, a and b, and you're going to equal your hypotenuse, c, squared. So the two shorter sides squared on the right triangle, has to be a right triangle, will equal the hypotenuse squared. All right, so to build our problem here, now that we know where our legs are, that's what this is talking about, and where the hypotenuse is. All right, it says one leg of the right triangle is 3 feet longer than the other leg. So because B is the longer side here, I'm going to assume that they're talking about this leg is 3 feet longer than this leg. So B is going to be, I could say A plus 3, but if you want to use variable x's, you can change them all to x's. You could use these variables. It doesn't matter. So if we call the short leg x, because that's the one we don't know anything about, the longer leg is x plus 3, and then your hypotenuse is the 15. So plugging those into your Pythagorean theorem, x squared plus x plus 3 squared equals 15 squared. So we're going to have to FOIL this out. X squared plus 3x plus 3x plus 9. 15 squared is 225, and so what we have to do is set this equal to 0. So we're going to have to combine these two x squareds, that's 2x squared. We're going to get a plus of 6x, and then we have to subtract over the 225. So 9 minus 225 is a minus 216. Now it's set equal to 0. Well, to solve this, notice that we have all even coefficients. So let's take out a GCF of a 2. We don't need the 2 anymore. We can throw it out. Focus here. What two numbers multiply to be 108 and subtract to be 3? Again, 3 is a small number. I can do my square root idea here again. Second square root of that 108 is 10.39. So it's got to be somewhere around 10. Okay, so let's see. I'm thinking 9 and 12. 9 times 12 is 108. So the 12 gets the plus sign. The 9 gets the minus sign. Again, you don't need the 2. We can throw that out. X plus 12 equals 0 means x equals negative 12. And x is equal to 9. Wait a minute. Just like the cutting board, we can't have a side of our triangle be negative. So we throw out the negative 12. So the short leg A, that's going to be the 9. The longer leg B is going to be 9 plus 3, which is 12. So the other two sides are 9 feet and 12 feet long. All right, our next problem. Oh, look at all this verbiage. Holy cow. Don't panic. One thing authors love to do with word problems is give you so many words you get confused. I'm going to look at this problem as a whole right now, and here's the best part. They gave me the equation. So here, these past problems here, I had to make my own equation. They already gave me the equation. So when I read this problem, I just want to find out what does the t represent and what does the n represent, and I need to substitute something in for those numbers. So I'm going to read this to know what does the t and what does the n mean and what do they stand for. So something I can substitute in. It says for certain people suffering from extreme allergy reaction, the drug epinephrine is sometimes prescribed. The number of micrograms n of epinephrine in an adult's bloodstream t minutes after 250 micrograms, that's the n, have been injected can be approximated by this equation. How long after an injection will there be about 210 micrograms of epinephrine in the bloodstream? Okay, so they inject 250 micrograms. They want to know when are there 210 micrograms left over. So they're wanting to know when has the body already absorbed 40 micrograms out of the bloodstream. All right, so 210 goes in for n. Okay, so set it equal to 0, subtract over the 210. We don't want this negative 10 here, so let's GCF that out as a negative 10. We can get rid of it, remember. Now I'm left with t squared minus 10t plus 21. What two numbers multiply to be 21 and add up to be negative 10? How about t minus 3 and t minus 7? Again, throw out the negative 10, so t is equal to 3 and t is equal to 7. So we have two answers here. At 3 minutes and 7 minutes, there's 210 micrograms in the bloodstream. And you might question, how is that possible? Well, once you inject 250 micrograms, as it's entering the body, some is still in the syringe and some is being entered. So there might be entering this in probably through an IV. So the IV, they put 210, they inject it into the IV. In 3 minutes, there's 210 micrograms in there. It's still increasing. When it probably gets to somewhere in between 5 minutes, it's at 250. And then it starts to get absorbed by the blood, and then we're back in 7 minutes back to 210. So two possible answers here. All right, two more examples here. Let's see what we got. A zip line canopy tour in Alaska includes a cable that slopes downward from a height of 135 feet to a height of 100 feet. The trees that the cable connects are 120 feet apart. Find the minimum length of this cable. So we're looking at a right triangle here. So to label this, the first tree 135 feet tall, the second tree right here 100 feet tall. They're skinny trees. These trees are connected 120 feet apart. Okay, what's the length of my cable? Well, I know that if this is 130 feet, 35 feet tall, this is 100 feet tall. If I subtract 100 from 35, this side of my right triangle is 35. This is my hypotenuse C. Folks, this is just the Pythagorean theorem. 25 squared plus 120 squared equals C squared. Square the numbers, add them up. Okay, subtract over 15,625. This better be a perfect square, so take the square root of that. It's 125. You can't have a negative value, so C is 125. That's the minimum length of that cable right there. A bridge design. A 50-foot diagonal brace on the bridge connects a support at the center of the bridge to a side support of the bridge. The horizontal distance that it spans is 10 feet longer than the height that it reaches on the side of the bridge. Find both distances. Okay, this is a bridge which has a right triangle going to the middle, and then there'll be another right triangle over here. But we're just going to work on this side. So a 50-foot diagonal brace connects the center of the bridge, that's the height, and the horizontal distance is 10 feet longer than the height. This will be h plus 10. There's my right triangle. Use your Pythagorean theorem. H squared plus the binomial h plus 10 squared equals 50 squared. So we're going to FOIL this out, very similar to we saw that other problem. H squared, we have h squared plus 10h plus 10h plus 100 equals 2,500. Combine 2h squared plus 20h, subtract over the 2,500 minus 2,400. We have a GCF of 2 to take out of each term. We can throw out that 2, focus here, h squared plus 10h minus 1,200. Now here, talk you a little trick here. Since this constant right here, what two numbers multiply to be 1,200 and subtract to be 10? Because there's two zeros, your number has to end in zeros. And if I'm subtracting and it ends in a 0, it has to end in zeros. So think of it this way. Drop off these two zeros, drop off this 0. What two numbers multiply to be 12 and subtract to be a 1? 4 and 3. Put the zeros back on those numbers. 40 and 30. So plus 40 minus 30. That's the zero trick at the end of numbers. If I have two zeros, it's probably going to, and you have to add or subtract to be a number that ends in a 0, your numbers must end in zeros. So we have h equals a negative 40. Nope, can't have that. Throw it out. H equals 30. So 30 is the height. 30 plus 10. 40 feet is the horizontal distance. All right, next we have a number is 6 less than its square. Find all such numbers. This is an interesting problem because there's a lot of possibilities here. So a number, I don't know what that is. That's my x. Is the equal sign. 6 less than. Less than means the 6 has to be on the far right, and I have to subtract it from its square. What is its referring to? Its is referring to the number. X squared minus 6. All right, so set it equal to 0, subtract over the x, factor and solve. All right, two numbers multiply to be 6 and subtract to be 1. We've got a minus 3 and a positive 2. X equals negative 2, x equals 3. So we have to put in the negative 2 to see if it works. It does. Put in the 3, see if that substitute in and it works. This would be the calculator by hand. If you're checking it here, this is what the calculator does. All right. Okay, so that wraps up 5, 7, and 5, 8.